We will begin this video lecture series from Chapter 6 of the Practice of Statistics, 4th edition, discussing probability distributions. The goal of the video is for you to learn how to create a probability distribution and also how to find probabilities of compound events using those distributions. So here's the first example. The following question was posted by David Sissel of Mobile, Alabama in the Ask Maryland column of Parade magazine. My daughter is carrying triplets, gender unknown. We're trying to determine the odds of each possibility. My thinking, there are 4 possible combinations: boy, 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 girl, 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 boy, girl, girl, and girl, boy, boy, and birth order doesn't matter. So the chances are 25% for any of them, correct? We're going to analyze this example, determine the likelihood of each event, and then move on to answer Mr. Sissel's question. Let's begin. The first step is to list the sample space for the birth combinations. In other words, we need to pay attention to what are the possible outcomes of birth. And contrary to what Mr. Sissel believes, order does matter. If you have siblings, you know it matters who's the older child, who's the younger child. It makes a difference. So let's list these birth combinations. So here's our sample space. We can have boy, 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 girl, boy, girl, boy, boy, girl, girl, or girl, 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 boy, girl, boy, girl, girl, boy, boy. And again, all of these are different combinations because the order does matter. For example, boy, boy, girl says that you have an oldest boy and then a middle child that's a boy and then a youngest child that's a girl. Boy, girl, boy, even though there are 2 boys and a girl, say that the oldest and youngest children are boys, but the middle child is a girl. So in this case, order does make a difference. In step 2, we need to determine the likelihood of each of these combinations. Now, we know that the probability of being born boy is 0.5, and the probability of being born girl is 0.5. Of course, we're leaving this all up to chance. So, when I want to have 3 boys, the probability of boy, 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 these are all independent events. So this is a result of having 0.5 for the first boy, 0.5 for the second boy, and 0.5 for the third boy, which is a probability of 0.125. Now, because each of these individual events, being born boy and being born girl, are equally likely, then each combination that we have will have 0.5 times 0.5 times 0.5, which is 0.125. So all combinations are equally likely, and they will all equal 0.05. Now, I want to make it really clear that these events are equally likely because the individual events of being boy and being girl are equally likely, not because there are 8 combinations and 1 out of 8 is 0.125. I'll say that again. All of these combinations are equally likely because the probability of being boy equals the probability of being girl. And when I multiply those in succession, I get 0.125 for each of these. Had the probability of being boy be different, such as 0.6, and the probability of girl was 0.4, then I would not have the same scenario where each of these 8 combinations has the probability of 0.125. It's not because we have 8 possibilities and we're choosing one of them. It's because the original event of being a boy or being a girl these events are equally likely. Now we're going to move on to create the probability distribution. The probability distribution of a random variable shows the values that that variable can take on, as well as the probability of each of those values occurring. We're going to define the variable. This is required for every problem that we do in this course, no matter what we're doing. Define your variable. Here, we're going to let x equal the number of expected number of boys a couple could be carrying. And then to create the probability distribution, we're going to create a table. We can also do this in a histogram. We'll look at this in class. So, out of 3 children, triplets, the couple could have no boys at all, 1 boy, 2 boys, or 3 boys. So we're going to use the sample space that we just saw and look at the probability of each of those occurrences. Now, the couple will have no boys if the outcome is girl, girl, girl. And the probability of having girl, girl, girl is 0.125. The couple will have 1 boy under 3 different conditions. That is, boy, girl, 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 boy, or girl, boy, girl. Each of these has a 0.125 chance of happening. So this is 0.125 times 3, or 0.125 added for each combination. So we have 0.375 as the option for probability. A couple will have 2 boys in the following combinations. There are 3 of those also. Boy, boy, girl, boy, girl, boy, and girl, boy, boy. Again, with each of these events being equally likely, 0.125 for each event, this one, or this one, or this one, we're going to add those together, 0.125 each to get 0.375. Lastly, the only way for the couple to have 3 boys is to have boy, 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 and we saw that that probability was 0.125. Now, let's look at the probability distribution itself, and we found these, and so now we can begin to answer Mr. Sissel's question. Based on what we've done so far, first of all, we can tell Mr. Sissel that there are actually 8 possibilities. In addition to the ones listed, we have these. We have boy, boy, girl, boy, girl, boy, girl, girl, boy, and girl, boy, girl. Again, these are in addition to the ones that Mr. Sissel named. The final thing we want Mr. Sissel to understand is that we cannot find the probabilities of these combinations by simply dividing 1 by however many there are. We must consider the individual probabilities that make up the compound event. So, each combination has a 1 in 8 chance of occurring. And this is because the probability of having a boy is equal to the probability of having a girl, which is 0.5. And when I consider the probability of having, for example, a boy first, and a boy second, and a boy third, then I must multiply those individual probabilities together to come up with 0.125. So in summary, through this video, you have learned how to use the sample space of a random event to create a probability distribution, and you've also used it to help answer Mr. Sissel's question of the possibilities for triplets, birth order, as well as gender for his daughter. Watch this as many times as you need. Also be sure that you read, use the reading guide. It is a guide for your reading, and I will see you in class.